12 bits, 8 bits. How we are going to plan? Suppose in an organization, student LAN is there, faculty LAN, admin LAN. So how we are going to plan it perfectly? So that suppose what is the plan? And you suppose can see check it address 11715
Local area
student,
network.
and this is the conversation. How we are going to plan? That means suppose 8 bits 15 student will not allow to edit. Only faculty and admin can edit. Network address. Then rest we need to implement access control list. Bits are belongs to host. SCL. Right? Suppose if we do not do subnet, then we cannot implement access control list. That means so for that purpose we need to plan accordingly. How who are the end users who will use our view or edit our file? So some restrictions should be given. For that purpose, subnetting is required. Number of regions of subnet. Large network needs to be segmented into smaller subnets, creating smaller groups of devices and services in order to control traffic, reduce overall network traffic. 192 is converted to subnetting. Process of subnetting a network into smaller network spaces called subnetworks. One is converted to binary format, and this 8 times 0, I need to borrow one. So I am just showing one example here. Networks. That means I have 8 plus 8 plus given an IP address called 192.168.1.0/24. Then 25. Its subnet mask will be from the right side because it's a class C IP address /24. That means 24 bits are network bits. Yes, 8 bits are host bits. What's left? That means 255.255.255.0. So here, if it is 25, then I need to borrow one right side is 1 because 0 bit towards one network. It will change the bit. Subnet mask will change. Right. That means whenever I am calculating the subnet mask, so this is how practically we need to calculate subnets in use. Network address 192.168.1.0. 1.0/25. Second, that is 8 bits are class C IP address 255. Third 8 bits are and 25 bits are network. Fourth part, if it is 25 bits are network bits, then suppose anyone can ask us what is the network address, what is the fast source address, what is the last source address, what is the broadcast address. This one, these basic questions will come.
Yes, sir.
When calculating for subnet, it is asking /20. That means 192.168.1.0. 10 from
borrow
one more right side ones. That means 192 plus. That means 192.168.1.0 is the network address. Fast source is plus 192.168.1.0. Getting all of you 7 bits are 0 plus 1. That means 192.168.1.1 will be 255.255.255. Last source and broadcast address. First, we need to calculate the broadcast. Broadcast address before address is the last one. Broadcast address, yes, how I will calculate? All the host bits are 1. So calculating 192.168.1.0 followed by 7 times 0. 7 times 1. That means 192.168.1.127. Organization, that is corporate office, legal office. This is the broadcast address. If we minus 1 that is 192.168.1.126 is my last host address. Then this kind of subnetting is required. Yes, everyone got this? How I am quickly calculating this one? Network address, broadcast address, fast host, last host, I can calculate easily. To the server, not just I. Yes, everyone understood? 127.0.
Sir, we have to remember this all addresses.
Then it will show the. No, you no need to remember. Only you need to remember which class of IP address is connected to the server. 192.168.1.0/25. This is a class C address.
Sir, can you show the previous
class C means? Okay. First 8 bits are
255.255.255.
Is basically yes, that one I have already calculated. But here I am calculating the network address, broadcast address, fast source, last source, subnet mask. You can add the subnet mask. So that address range from 1. That means fast source is host 192.168.1.0, last source 192.168.1.127. IP address, sorry, 126 is the last source, 127 is the broadcast address, fast source 192.168.1.1. This is the fast source. And the subnet mask going to plan. Subnet mask is the 255.255.255 admin LAN. got 128 perfectly. Yes, everyone understood what I am saying? Yes,
Local area network.
can I proceed? How we are going to play? Yes, thank you.
Yes, sir.
So what I told, these things are given here in pictorial format. We need to implement access control list. So this question I basically asked to my student because I have already done for slash 25. So student can do for slash 26, 192, 168.1.0 slash 26. All can practice this one and you can get the network address. So some restrictions should be given for that purpose. Host address, large host address, large network need to be segmented into smaller subnets, creating smaller group subnets. Yes, all of you can calculate services in order to control traffic, reduce overall network traffic. If you calculate for slash 25, you can calculate for slash 26. Subnetting. Definitely. Or slash 27, slash 28, like that. Network spaces called subnetworks, subnets. Suppose one IP address is given, it is asking for 8 subnets. So then how we can calculate? 8 subnet means, suppose question is asking, one class of IP address is given, 192.168.1.0. Find out 8 subnets. Then 8 subnet means subnet mask will be 8 departments. Because it's suppose there are in our organization, HR, that means production, sales, 8 bits are host bits, corporate. So like that, if 8 departments are there, I can easily implement 8 subnets, each subnet to each department. Like that, you can see here 192.168.1.0. I have started. And 1.1 is the network address. First, 1.1 is the network. Last 1.30 is the last. Broadcast is the 1.31. Calculate. Next in use. Network 1.32. First word is 1.33. Last is 1.62. Broadcast is the 63. That is like that I can calculate the IP address if it is asking for 8 subnets. And the previous slide, whatever I have shown, this is for 4 subnets. 25 bits and 12 bits. Then suppose anyone can ask us, you can calculate what like this. Network address? What is the fast source? It is very easy to calculate. If you understood the concept, you can calculate it easily. Suppose it is asking for 4 subnets, 2 cap 4, it is that means 4. That means I need to borrow 2 bits from the right side. 0. If it is asking for 8 bits, 8 subnets, then right side 2 cap 3 means 3 bits you need to borrow from the right side. If it is asking 2 cap 4, that is 16, 4 bits you need to borrow from the right side. And you need to calculate. 7 bits are 0 plus 1. That means 192.168.1.1. So these things I have already told. If you have network, then you can discuss. First, we need to calculate the broadcast. Broadcast address before address is the last one. Broadcast address how we so subnet to meet network requirements. As per my requirements, I can calculate the subnet mask, then subnet, as well as I can find out the fast source, last source, broadcast address, network address, everything I can find out. This is the broadcast address. Then if this is subnetting is over, then a concept in networking is very important, that is supernetting. What is supernetting? Yes, super in subnet, I divide the larger networks into smaller networks. Whereas in case of supernetting, what I do? I can calculate. I easily use what I need to do this here. Yes, I use to combine multiple smaller networks into single large networks. That means subnet and supernet is opposite. Only into subnetting, I am class of IP dividing the larger network into smaller networks. Whereas in supernetting, I combine or merge multiple smaller networks into single and large networks. This process is also known as route aggregation, CIDR, classless interdomain already calculated. But here I am calculating how it is used. Suppose I am taking a class C IP address 192.168.1.0/24. That means then 2.0/24, 3.0/24, 4.0/24, 127. This is this 4 comes under 127 is the broadcast and its subnet mask is 255.255.255.0/24. And the subnet mask and in the right side I have converted its binary differential. From this binary differential, anyone can guess these things. What you can guess? Just check it thoroughly. Yes. 1.0, 2.0, 3.0, 4.0. What you can common
Yes.
think? Huh?
Can you please
So what I
explain
told,
about
these things are
supernetting
given
again?
here in pictorial format. Supernetting and subnetting. So in subnetting, I do because I have already done for divide small, larger network into small. So student can do. Whereas in case of supernetting, I combine the smaller networks into larger and you can get network. Network address means I combine all the small networks into one network. Host address, okay?
Yes, sir.
This is the
Understood.
definition. Last host address, just opposite. Broadcast address. Yes. Then in this supernetting, just convert each IP address into binary representer. If you calculate, I have represented, you can calculate convert into binary. Definitely. But what is the common thing? The first two octets, 192.168, are identical in all four addresses. Suppose one and focus on the third octet. One, asking for 8 2, 3, 4. Then how from above 6 bits are 0 and comma. Almost 6 bits. Total 16. Just check it. The first 16 bits are common in all addresses. In the third octet, the first 6 bits are common. Total common bits 16 plus 6, that is 24 bits. Production. So, if you combine those addresses, what you will get? Supernet address 192.168.0.0/22. Subnet mask 255.255.252.0. Range is 192.168.0.0 to 192.168.3.255. This is how I calculate the supernet because it's opposite of subnet. Okay, we need to calculate the first octets are identical. What are the common bits? 1.32. In the supernetting, I always 1.33. We always need to check it. What are the common bits? Like that, I can common bits are 6 bits are 0 common and 192.168 are whatever common. This is for then the third octet, the first 6 bits are common. So total 16 plus 6. You can calculate like this. That is 22. That's why I can calculate supernetting in this concept. You can calculate it easily. Then come to DSCP. What is DSCP? Dynamic Host Control Protocol. That means I need to borrow 2 bits. So I have in the previous slides, I have already discussed there are 2 ways to subnet and give the IP address. One is static, another is dynamic. Right. In dynamic, what things happen? One is DHCP discover, DHCP offer, DHCP request, DHCP closed. If you see this figure, this is one example how this is being organized. If you have networks, then you can see one client is discovered. It is sending its IP address, destination, address, everything it is transaction ID, everything it is sending to the server. Server is acknowledging that yes, I can give you one address and you use it. This is known as three-way handshake process. TCP client server scenario. In three-way handshake process, whenever a client is being very important, that is supernet connected with the server, he sends a hi message and he replies DHCP gives its IP address, limit time, how much time you can use it, subnet mask, everything is given to the client message. The client message replies, and in this three-way handshake process, client gets a IP address. Subnetting, I am dividing the
So it is like TCP connection or UDP connection.
This is you can see in server client architecture TCP connection is also transmission control protocol TCP/IP serial protocol because it's an acknowledgement. In TCP we get acknowledgement, whereas in case of UDP we do not get any kind of acknowledgement. So this is a three-way handshake process. /24 means acknowledgement is getting. If there are many types of TCP transmissions also there, but it is you can say three-way handshake process. Okay.
So basically, it's a stateless
On the
protocol.
right side,
It
I have
follows.
converted its binary. No, just whenever a new client is discovered in a network, it sends a message to give an IP address to that system. And DHCP from its full of IP address,
Sir,
it assigns the IP
can you
address to the
please
client,
explain
and
about
client uses
supernetting
it
again?
whenever he or she switches. The owner switches the machine. That IP goes to DHCP, and any other system again wants to access it, he or she can access it. Getting? Whereas in case of
Okay, sir.
supernetting, I classifying routing protocols. So in this session, we will also see there are different types of routing classifications also there. One is static and second one is dynamic.
Yes, sir.
In case of static routing, things go statically, means manually we need to do. In case of dynamic, there are two types: interrogator protocol, exterrogator protocol. Again, interrogator protocol is of two types. It's two types. One is rich and vector, another linked set routing. Exterrogator protocol is path vector routing. It is one type, and rich and vector is again two types. Read person 1, person 2, EIGRP. Then linked set, OSPF, easy. Path vector routing protocol, BGP. These are the classification routing protocols. You can see these are the evolution of dynamic routing protocols. When the in late 1980s, these protocols came into picture. Purpose of dynamic routing protocol, why dynamic routing protocol is basically used. Discover the remote networks, maintain updated routing information, dynamically updates its routing table. That's it. That means whenever new network comes, the router updates automatically. And it choose the best path. So best service path from source to destination. So purpose of dynamic routing protocols, data structures, routing protocol message algorithms like Digextra. It also used here in finding shortest path routing protocols. So components of routing protocol, this is the components. I can calculate just for visualization purpose how components work. Then come to DHCP. Advantages and disadvantages, automatically share information about remote networks, determine the best path each network and add the information to their routing table. Compared to static routing, dynamic routing protocols require less administrative overhead because it automatically do everything. So a lot of good advantages are there in the dynamic routing. Using static routing, we need to provide the everything manually. If you see this figure, path also we need to keep it being organized. So using static routing, suppose this is the figure of a network. If we are using static routing, then I need to go to router 1, router 2, two routers are there. I need to give the router 1 which port is connected through which I can give you one system, which system is connected to which port. I need to give it manually. Whereas in case of dynamics, I no need to do the things. I will in the further slides I will tell these things. So static routing advantages and disadvantages. Static routing basically for smaller network, not for larger networks. So dynamic routing scorecard. So how dynamic routing is better than static routing? So I will go directly to how a dynamic routing is basically used. See in this figure, if you can check it, router
Sir,
first
it is
router,
like
second,
TCP
third.
connection or UDP connection.
Router 1. This is you can see one port FA0/0 one port that is another port S000 that is serial. This is Ethernet port FA0/0 is connected to 10.1.0.0 to router 0. Suppose first router 0, second is router 1, third is router 1, router 2. Then the network address 10.1.0 is directly connected with router to port number FA0/0. Whereas 10.0.2.0.0 is directly
So
connected
basically,
with
it's
the
a stateless
router
protocol.
0 with
It follows.
via port number S0/0.0. Just suppose I have connected another router 10.3.0.0. Then what things will happen here in router 0 routing table? It will see it assigns the IP address. The 10.3.0.0 is not directly connected with router 0, but it is connected via port S0/0/0 again. And sub count. What is sub count? Sub count means, suppose I am calculating the distance from router 0 to 10.3.0.0. That is sub count is 1. 10.4.0.0 count is 2. Because so 2 router I am getting that network. One is static and yes, you can check it here. Dynamic. In case of static, so in router 1, first table router 1, second table router 3, third table router 3. Router 2 is the second router 3 is the third router. You can check it. Again, interior 10.1.0.0 is connected with the interface FA0/0 directly. Of count 0. Whereas 10.2.0.0 it is also directly connected to serial port S0/0/0 of count 0. And 10.3.0.0 is not directly connected to router 1. So of count is 1. Okay, similarly you can calculate for router 2. Similarly you can calculate for router 3. Path vector routing protocol BGP. These are the classification routing. This is routing table. Updation. Updation takes place. Suppose any network is connected through dynamic routing protocol. In late 1980, these protocols came to especially routing information. The routing table always dynamic routing protocol. Dynamic updated protocol is basically used within fraction of seconds. If a network is being connected with any network, it shares the network. That means everything is shared. When a new network comes, the router updates automatically. And so what is convergence? Best service path. Convergence time is the time it takes router to share information, calculate best path, and update the routing. So purpose of that means, suppose one network is connected with another network. The time it takes to pass the information from one network to another network is known as convergence. Routing protocol. It also calculates best path and update the routing table. So network is not completely operable until the network has convergence. Convergence properties include speed of propagation of routing information and the calculation of disadvantages. Optimal path is basically find out by digit algorithm, which we have studied in ongoing subject digit algorithm. Compared to static routing, dynamic routing protocols require less administrative. Distance vector routing protocols. What are the different distance vector routing protocols are there? Read version 1, routing infrastructure protocol version 1, read version 2, IGRP, EIGRP. IGRP stands for Interior Gateway Routing Protocol. EIGRP stands for Extended Interior Gateway Routing Protocol. So this session is basically for our theory purpose. So this implements a required Cisco packet tracer where we can simulate those things. Through which algorithms. Which system is connected? There are two algorithms, distance vector and link state routing. Distance vector protocol use routers as sign port along the path to final destination. Whereas the link state routing protocol is like having complete map on the network. So static routing advantages. Okay. So this is the difference basically. For smaller network. Link state routing protocol are of two types. OSPF routing open subnet path static routing. So there are classful routing protocols also there. Classful routing protocol don't send subnet mask information to the routing update. Read person 1 and IGRP are classful. First router, second, third. Okay. Router 1. Classless routing protocols. What are the different classless routing protocols? Classless routing protocol includes subnet mask information. That is, in classful, we don't give subnet mask to the routing table. Whereas in classless, we give FA0/0 routing connected to 10.1. Protocol which includes subnet mask information. Read version 2, EIGRP, OSPF, EGs, support DLSS, variable length subnet mask, CIDR. Now, IP version 6, routing protocol. Directly connected with routing to port number FA0. So this is the routing protocol characteristics. That is, characteristics are speed, convergence, scalability, size of network, use of VLSM, resource usage, implementation, maintenance, etc. Suppose you. So distance vector technologies. What are the different distance vector technology vectors protocols are there? Read version 1, read version 2, IGRP, EIGRP. It will see that distance vector algorithms. Bellman-Ford is not directly connected. Algorithm is basically used for distance vector 0. but it is connected via port S0 or digit algorithm also used. And sub count. What is sub count? Routing information protocols. You can see there are two types: reef version 1, reef version 2. Router 02 and reef version 1 does not support BLSM, CIDR, it does not support summarization, also not supports authentication, not supervised. Reef version 2, it's an advanced version. It's about BLSM, CIDR, summarization, authentication. It supports. So in router 1, first step router 1, then IGRP and EIGRP. So similarly, IGRP does not support BLSM, CIDR, summarization, whereas EIGRP supports. 10.1.0.0 is shortest path first protocol. So shortest path first protocol is interrogated protocol, that is linked routing protocols. What are the different linked routing protocols? That is digit algorithm basically used for linked routing protocol calculator. From one node to another node, shortest path finding purpose, we use digit algorithm. So these are the linked state updates. How linked state is being updated? One network, IP address, type of network, or of that link, neighborhoods. Everything is updated with the routing table, as we have previously discussed. The routing table always. So while creating network, we can send hello message whether my packet is being delivered one network to another network or not. I can check it also. Shares the network address. Everything it shares. Building the SPF tree. This is also we can build. So how we can build? Because R1 is connected to R2. Here, one network 10.1.0/16 is directly connected. 10.2.0.16 is also connected to which port? What is the distance? Everything it can show. Network is known as convergence. It also calculates base path and update the routing table. So this is also how we can calculate the shortest path through digit algorithm. If we implement reef protocols and reef version 1, reef version 2, it will show. Optimal path is basically find out. So I am quickly overcome those things because these are basically related to lab experiments where we need to implement the reef protocols or IGRP protocol, EIGRP protocol, or EGs for the students. Routing infrastructure protocol. So these are my references where I have taken my this PPT preparation, Cisco system IP addressing subnetting for new users, and introduction to IP for IPC addressing Cisco Network Academy, subnetting concept and practices, and one of my book I have also published, Cisco Packet Tracer Implementation, Building and Configuring Networks, which is available on Amazon and Amazon.com and .in and other leading online portals. It is also available. And CCNA routing and switching study guide, CCNA official certificate guide library, computer networking principle, protocols and practice. This book also you can refer. So these are my references. Are of two types. OSPF. Thank you.
Sir, can you share the PDF?
Yes, I can share. I will share to the organizer and they will send it to the students. And any question anyone having mass information to the routing updates.
Sir, when will get the certificate?
IGRP class 4. A certificate the organization will provide. Apart from that, any question regarding to my today's webinar and or because this completely needs lab practice somehow, we need to implement those algorithms. Then we can know how it is working, how the packets are moving. Those things require lab implementation, strong lab implementation required. OSPF, EGs support DLSM, variable length subnet mask. Apart from that, any question? Anyone having routing protocols in subnetting, supernetting, or RIP protocols? Routing protocol characteristics. That is, characteristics are speed, convergence, scalability. I think no question from the any DLSM, resource usage, maintenance, etc., etc. Okay, thank you. So distance vector technologies. What are the different distance vector technology vectors? Protocols are there. Thank you for the participation, active participation. To everyone.
Thank you, sir.
EIGRP. Thank you.
Thank you, sir.
Distance vector algorithms. Bellman-Ford algorithm is basically used for distance vector implementation purpose. Or digit algorithm also uses. Routing information protocol. You can see There are two types: REAP version 1, REAP version 2. And REAP version 1 does not support BLSM, CIDR. It does not support summarize, and also not supports authentication, not support. Whereas REAP version 2, it's an advanced version. It's about BLSM, CIDR, summarize, and authentication. It supports. Then IGRP and EIGRP. So similarly, IGRP does not support DLSM, CIDR, summarization, whereas EIGRP supports. Shortest path first protocol. So shortest path first protocol is interrogated protocol, that is linked routing protocols. What are the different linked routing protocols? That is Digikestra algorithm basically used for linked routing protocol calculation. From one node to another node, shortest path finding purpose, we use Digikestra algorithm. So these are the linked state updates. How linked state is being updated? One network, IP address, type of network, or of that link, neighborhoods. Everything is updated with the routing table, as we have previously discussed. So while creating network, we can send hello message whether my packet is being delivered one network to another network or not. I can check it also. Building the SPF tree. This is also we can build. How we can build? Because R1 is connected to R2. Here, one network 10.1.0/16 is directly connected to 10.2.0.16. It is also connected to which port, what is the distance, everything it can show. So this is also how we can calculate the shortest path through Digikestra algorithm. If we implement REAP protocols and REAP version 1, REAP version 2, it will show. So I am quickly overcome those things because these are basically related to lab experiments where we need to implement the REAP protocols or IGRP protocol, EIGRP protocol, or EGs for the students. So these are my references where I have taken my this PPT preparation, Cisco system IP addressing subnetting for new users, and introduction to IP4 IPC addressing Cisco Network Academy, subnetting concept and practices. And one of my book I have also published, Cisco Packet Tracer Implementation, Building and Configuring Networks, which is available on Amazon and Amazon.com and .in and other leading online portals. It is also available.